In problems 5 through 7, we are determining the sample size needed to estimate either a proportion or a mean. And we use a different formula depending on whether we're working with a proportion or a mean. And those formulas are given on the final exam. So in this problem, we're determining the sample size needed to estimate a proportion. So my formula is n is equal to p hat times 1 minus p hat. And sometimes the hat is there, sometimes not. So either p or p hat. It's just a preliminary estimate for the proportion that we want to estimate. Times z sub alpha over 2 over the margin of error, and we square that. Now, in this particular problem, we don't have a preliminary estimate for the proportion, so we use 0.5 for that. So I have 0.5 times 1 minus 0.5, and in your book they just work this out and say use 0.25 when you don't have a preliminary estimate. So you can either do that or you can just plug in 0.5. Either way you're going to get the same result. Next we need z sub alpha over 2, and I'm going to have to calculate that. So let's plug in the margin of error, which is 0.04, because it's 4%. And so now I'll find my z value off to the side. Because we have 90% confidence, what I'm going to do is sketch the distribution and say that we have 90% in the center. The z value is actually this value right here on the right-hand side. So if there's 90% in the center, that means that there's 5% in each tail. So we take, to get those 5%, we do 100% minus the 90 in the middle. That gives us 10%. And then we divide that 10% by 2 to get 5%. So that's how we have 5% in each tail. And I'm going to calculate inverse norm on the calculator of 5%. And when I do this, I get negative 1.64. It doesn't matter whether you use negative or positive, really, because we're going to square that value anyhow. So we have 1.64 here. I'm not going to bother to put in the negative. And when I put that all into the calculator, I get 420.25. And because we have to always round up or go up to the next whole number, then we're going to say our answer is 421. So it's not really rounding because I don't look to see what number is here. I don't care. I just say we need more than 420, then we have to go up to 421. And so that's my answer for number 5. In number 6, we want to determine the sample size needed to estimate a proportion. So again, we'll use p hat times 1 minus p hat, z sub alpha over 2 over the margin of error squared. Now in this problem we have a preliminary estimate, which is 0.27. So we put in 0.27 times 1 minus 0.27. Again, I'm going to have to calculate z sub alpha over 2. So margin of error is 0.3. Let me square here. So in this case we have 95% confidence. So we're going to get a different z value. 95% in the middle. And you don't have to draw the figure, but I feel like it helps me, so I'd like to do it. And that gives me 2.5% in each tail. And I calculate inverse norm of 0.025. and this gives me negative 1.96. And notice that I'm rounding that value to 2 decimal places as instructed. So make sure you round to 2 decimal places because it can throw off your answer if you don't follow those directions. So once I type this all into the calculator, I get 841.3104, which of course we take to 842. So that's my answer there. In number 7, now we want to determine the sample size needed to estimate a mean. So we're going to use n equals z sub alpha over 2 times sigma over the margin of error squared. And we have sigma is the standard deviation, so that's 20 over margin of error is 1.5. And so I just need to calculate z sub alpha over 2. And here we have 98% confidence. So if there's 98% in the center, that means 1% in each tail. And so we're going to find inverse norm of 0.01, and that is negative 2.33. So I'll put 2.33 in for z. And when I calculate this, I get 965.13777778, and that becomes 966. So that's how you work those problems.